Okay, we're going to talk about the two index laws, the laws of indices, when it comes to multiplying and dividing powers. So if you have repeated multiplication, you can express it as a base, which is a number or a variable, and then an index, plural of which is indices. So you can go home and tell your parents about that one. So if we look here, we have the base. Here it's a to the nth power, to the power of n. So that would be a times a times a to whatever n is. So a practical example is our base number is 2, and how many times we multiply 2 by itself? There are 6 2's. So 2 times itself, it's not 2 times 6, of course. So an expression of 4x to the power of 3, or cubed, can be written out just as you would expand 4 times x. You just keep multiplying the additional x's until you have 3 of them, because you're at the power of 3. So multiplying is index law number 1. If you're multiplying powers with the same base, and it's important, like a to the power of m and a to the power of n, you can just add those powers together. So there you go. So the answer of a to the power of 4 multiplied by a squared gives you a to the power of 6. And if you're dividing, I'll bet you can guess, you've got the same base again. Division, another way to look at it is like this, is the same as subtracting them from each other. So if you had a to the power of 8, then divide that by a to the power of 5. 8 minus 5 gives you 3, which is the French word for 3. So let's have a look. So I'm going to be multiplying. Do I have the same base? Yeah, we're cooking with gas. So I'm going to add up 5 to the power of 3 plus 7 plus 2. Well, that was sloppy. Let's see, what does that give me? I can work that out in my head. That's 5 to the power of 10, 11, 12. So all I did was add these together. If you want to really think about it, let me show you a different way to think about it. So 5 to the power of 3 is 5 times 5 times 5. That's this first one, okay? And then we get 5 to the power of 7, and we're multiplying by that. So we get times. And then I'm going to multiply that, goodness gracious, by an easier one, 5 to the power of 2. So how many 5s have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my gosh, it works. Surely it's much faster to do it the first way. So let's do the next ones the first way. Here we go. So for b, we have x to the power of 3 times x to the power of 4. And I just add those together, and I get x to the power of 7. So now we have a bit of a doozy here. We've got x to the power of 5, just a plain old a, and then a to the power of 3. And so, of course, what we know, that isn't just plain old a, that's a to the power of 1. So what we're going to end up with is our base, which is all the same, to the power of 5, adding the 1, adding the 3, adding those powers together. So we get a to the power of 9. So don't miss that little puppy out here. And now we've just got issues here, right? We've got issues. But luckily we know what to do. So we can reorder this so that it makes a bit of sense to us. We'll put the coefficients together first because we're multiplying everybody together. So this is just another way of saying we're multiplying by times x to the 4th. And is there another x in there? There sure is. X squared. Keep on multiplying y to the cube, y cubed, times y 8. So another way to write that is 5 times 2 is 10. We can work that out. Times x to the power of 4 plus 2 times y to the power of 3 plus 8. And that leaves us with the grand equation of 10, 4, 5, 6, x to the 6, y to the 11. And it works. Going the other way, we're dividing, we're going to subtract. So again, do we have the same base? We do. They're both 10s. And I have my example, 10 to the power of 8 divided by, that's what that means, divided by. It's the same as saying this. So I'm going to do 10 to the power of 8 minus the power of 5 gives me 10 to the power of 3. U to the power of 20 minus 5 gives us u to the power of 15, because that is the same as saying, u to the power of 20 divided by u to the power of 5. And again, we've got a common base. Now over here, I think it might be more fun if we can just do some canceling. What's a common factor between 10 and 4? Let's see, 2. So 2 times 5 makes 10. That's our top number. And we still have times x to the 6th. And then we have 2 times 2. If you would rather think about them as canceling, let's do x times x times x. What's that? 3, 4, 5, 6. And down here we have 4. 1, 2. Sorry, we only have 2, don't we? Silly, because it's x to the power of 2. So what can I cancel? Now this top is 10 times x to the power of 6. I've just factored out the 2 that's common to both 10 and 4. So that leaves us with 5. But look, we can also take out a couple of these puppies. And we only actually have, because we've taken those 2 off the bottom, we don't have any x's on the bottom anymore. We've got x to the power of 4. There we go. And the last puppy here, again, if you want me to write out, if you want to sit there and write out 10 a's and then cancel out the 3 a's that are on the bottom, we can do that. But essentially we have over here 10 minus 3, and that's going to go a to the power of 7, and then these are common bases. 6 minus 2 times b to the power of 4. It doesn't need to be a fraction anymore because we've actually just canceled out everything that's on the bottom. Right? Have fun.